Hello, welcome back to Cracking the Cryptic and another puzzle by Sudoku, our Korean correspondent, who I have found to is becoming a very reliable constructor of puzzles that I find very entertaining. So I'm quite keenly looking forward to having a go at Sigma or Pi. I will explain the rules in a moment. Of course, there are all of our apps. If you like a killer Sudoku, we have a killer Sudoku app. If you like Arrow or Thermo Sudoku, we have an app for that. And there's classic and approachable Sudoku and chess and all sorts of things. Do check them out, but the latest is Fog of War, and that is good fun too. You clear the fog to solve the puzzle. And of course we have SVEN'S SUDOKU PAD linked under the video, and all our merchandise, including the 2025 the Year of the Secret Squared t-shirt, which is fun, and loads going on, of course, on Patreon, where Simon solved the brilliant Sudoku Scrabble mashup, featuring a game between Martin and Stuart, with a surprising result. And I mean, it's very clever. It's an interesting puzzle. Do check it out. But there's also monthly Sudoku hunts. There's the solutions to those. April's is going to be a sort of April Fool themed hunt. We're looking forward to bringing that to you. Loads going on as always, and absolutely thrilling stuff on Patreon, connections and crossword videos too. But the first link under the video is to Sigma or Pi by Sudoku. Very simple rule set. Normal Sudoku rules apply. We're going to put 1 to 9 in every row, every column, and every 3 by 3 box. Digits in a cage may not repeat, and solvers must distinguish each type of cage. They are either showing as the number in the corner the sum of the digits or the product of the digits in the cage. So this one could be 2 digits multiplied together to 15 or 2 digits added together to give 15. This could be 4 digits multiplied together to give 30 or 4 digits added together to give 30. And that applies throughout the grid. I mean, it's a really, I'm not even sure, we might have done a puzzle with exactly this rule set before, a long time ago. We've certainly seen product cages before. It's a lovely idea though. Now, I do wonder about the title. Sigma, I know, is the Greek letter for a sum of something. Can pi be used for the product of something? I'm only familiar with pi as the transcendental, irrational circle ratio number. Maybe it can. I don't know. I'm such a non-mathematician, it's painful. Anyway, give it a try on that first link under the video. I'm going to give it a try now. Let's get cracking. In the central box. I mean, just glancing around the grid, I think this is entirely deliberate. I didn't find a cage which, given the number in its corner and its size, couldn't be done in at least 2 ways. So there seems to be, to me, there seems to be deliberately no giveaway cages. You can send a comment in if you think I'm wrong. And I might be. I mean, I'll probably find out as we go along. Anyway, however, in this central box, the first thing I'm going to say is that for these 2 4-cell 30 cages, they can't both be sum cages, because the only way of getting to 30 in 4 cells as a sum is 6, 7, 8, 9, when the cells have to be different. They can't both be product cages, because both cages would need a 5 in if that was the case. So one is a sum of 6, 7, 8, 9, the other is a product with a 5 in, and I think therefore, since the other digits have to multiply up to 6, they must be 1, 2, 3, and the central digit in the puzzle is a 4. Now, I don't think that takes us a long way forward, but it is nonetheless true. It doesn't, well, okay, the 24 cage, if it was a product cage, could have been 1, 4, 6. Now, if it's a product cage, it must be 1, 3, 8. Well, no, I don't know that. I've just thought of that as a possibility. 2, 3, 4 would work, but 4 has ruled that out. I hadn't thought of that. Okay, so I think that is it. If you've not got a 1 in the cage, it would have to be 2, 3, 4. If you have got a 1, it's either 1, 3, 8 or 1, 4, 6. So this is now either 1, 3, 8 or 9, 8, 7. 9, 8, 7 is the only possibility if 24 is a sum, and that means 8's definitely in the cage, which is not a big breakthrough. Are we looking at these two? So 16, 15, 12. I mean, I know that 16 and 15 can't both be sums because that would be 31, which is too many for 4 cells. Okay, let's start down in box 9 where we've got 16, 15, 14, which adds up at least to even more than 16, 15, 12. Right, so the two possibilities for the 16 cage are a 9, 7 sum and a 2, 8 multiplication. The 15 cage is either a 9, 6 or an 8, 7 sum or a 3, 5 multiplication. Again, there are 2 sums for the 14 cage or a 2, 7 multiplication. Now, oh bother, I was going to say, I was hoping that the 16 and the 14 couldn't both be sums, but they can. Those cages add up to 30. It would be 9, 7 and 8, 6. For a multiplication, both 14 and 16 would need a 2. (15) is either 3, 5, I don't know. I'm probably starting in the wrong point of the puzzle then. I did think about this box of 12 cages or this box of 10 cages. I didn't really get anywhere thinking about that. Okay, let's keep going here. Let's do some what ifs. This cannot be a 2, 7 cage. There we go. This can't be a product cage because if it was 2, 7, this couldn't be either 2, 8 or 9, 7. So now I need a colour for some cages. Let's make some cages yellow. That's the first one we know. And I don't know whether it's 8, 6 or 9, 5. But if it was 8, 6, this would have to be a sum of 9, 7. And this would be 3, 5. These would be 1, 2, 4. If this was 9, 5, this would have to be a product, 2, 8. And this wouldn't work at all. Yeah, that's right. Right, if this was 9, 5 in this 14 cage, this couldn't be 9, 7 as a sum, so it would be a 2, 8 product. And then this could neither be 9, 6 as a sum, because 9 would have been used there, 8, 7 as a sum, because 8 would have been used here, or 3, 5 as a product, because 5 would have been used here. That's quite complicated, but it's very clever, actually. So this is 6, 8. This now can't be 8, 2 as a product, so it's definitely 9, 7 as a sum. Now, 9, 8, 7, and 6 have all been used, so this is going to have to be a product. Let's use red. No, pink. 3, 5. And these are 1, 2, 4, which was the case I'd worked out. Right, is that telling me anything? I was looking up here, it doesn't tell, it tells me this 12 cage can't be a 6, 2 multiplication. But now it's either 3, 4 multiplication, 3, 9 sum, or 5, 7 sum. That's not as informative as I wanted. There is an argument to say that the 15 cage is unlikely to be a 3, 5 cage because of uniqueness, and the 16 cage is unlikely to be a 9, 7 cage for the same reason. But I'm not using it because one of the things we try and do in these puzzles is prove that the puzzle has a unique solution. And if you prove a step in a puzzle by uniqueness, it does not prove that there's a unique solution. So I'm not going to use that. What I'm going to do is say, where does 5 go in this cage now? because 5 is in one of those cells, so it's not in this 3-cell cage. In fact, there are questions to be asked in this box. Think about the numbers 9, 7, 5, and even 8. None of them are possible factors of 12. I might try the same tactic on the 10 box in a moment. Right, 9, 7, 5, and 8. None of them can be factors of 12. So they must be in some cages. All of 9, 8, 7, and 5 must be in some cages. Now, the 5, we now know, because it can't be there, is in a 2-cell cage. So one of these cages is a 5-7 cage. The fact that 7 is in one of those cells means the 7 is in one of these. The 5 is either there or in one of the, well, okay, I'm going to pencil mark that as well. 5's in one of those cells. Now, 3 is also forced out of this row into one of these cages, but that could be a 3-4 cage. However, I've still got to find room for 8. 8 cannot be in this cage now. It could have been earlier. It can't now, because it would have to be a sum cage with a 3 and a 1 in it, and we can't put 3 in it. So 8 is now in one of these as well. And it must be in a 2-cell cage, therefore, with a 4. And 9 could be here if this was 9, 2, 1. But what would that leave? Because we've got a 7-5 cage and an 8-4 cage. That would leave 3 and 6. And they neither multiply together nor add together to give 12. So 9 is in one of these as well. Sorry, I'm going to get rid of the pencil marking. But now we know that 9 is in one of these cages. It must be with a 3. So we have a 3, 9, a 4, 8, and a 5, 7. These are 1, 2, 6, and that does work as a multiplication. It makes this digit a 4. That is a really lovely break-in, actually. I think that's incredibly clever. 7 and 9 can't be in this row. That's what we know from this. This is now, in this row, a 7, 8, 9 triple. And that's going to do things to the 12 cage. It's going to make the 12 cage a product cage, because the high digit needed for a sum cage is not available now. It's really pretty, this. So this is, but I mean, this can now still be 6, 2 or 3, 4. And I don't know which it is. So maybe we haven't actually enabled ourselves to go north. Now, I said I would consider the 10 cage, and I'm going to. Right, 5. Oh, no, I was going to say 5 can't be in any of these cells. It's absolute nonsense, because a 5-2 cage is entirely possible and quite likely. Right, let's do the same thing, of course, as I was doing with the 12 cage. Let's consider factors that, or numbers that can't be factors. 9, 8. First of all, neither of those can be in the 10 cage, because that wouldn't leave room for enough digits to add to 10. So 9 and 8 must be in this group of cells. Now, 2 of these cages are sticking out of the box. And that means I can't necessarily confine 1 and 2 there. In fact, I have a feeling that 1 or 2 must be in one of these, because this is either a sum 10 cage, in which case it would need a 1 or a 2 in, or a product cage, in which case it's 1, 2, 5. Nine and 8 have to be up here. Yeah, I think with the cages sticking out of the box, actually this isn't a good place to approach from, so I'm giving up on that. Now we said this is either 6, 2 or 3, 4. The 7 and 9 are in this group of cells, so this can't be a 4, 8 cage anymore, or 7 and 9 would both have to be there. Does that do anything exciting? No. This is either 3... Oh, this one. This has to be 8, 4, doesn't it? Because it can't have a 9 or a 7 in. That's so blindingly obvious now. So I can take 8, 4 out of this one. That is a 3 or a 5. These are all sums. I should have remembered that. We've got 3, 9, 4, 8, and 5, 7. So this digit is 7 or 9. Okay. 4, 8 pair fixes the corner as a 6. 7 and 9 are used up here. So these digits are from 3, 4, 5, 6. And these from 1, 2, 3, 5. Now, this is a product cage. We've worked that out. This can't be 1 or 5. That is 2 or 3, going with another factor of 6 or 4. And that's about as much as I can do there. I really am going to have to get into this box now, because I don't think there's anywhere else I can really get at this from. So let's think about this. We've again got a 16 cage now. This 12 cage we said can't be, look, we've placed the 4. It can't be a product cage at all. It can't be 4 times 3 or 2 times 6. So it's definitely a sum cage of 2 odd digits, 3, 9 or 5, 7. Now, whichever one it is, you can't make this a 9, 7 cage. So that's definitely a product cage and must be 2, 8. This also is determined by the fact that this is either 3, 9 or 5, 7. This can't be a 3, 5 cage anymore, so that's a sum cage, and it doesn't have an 8 in it, so it's 6, 9. Lovely. This is so elegant. That's now a 5, 7 pair. We've got 1, 3 and 4 left to place in the box. That one can't be a 4. Now, that's lovely. I mean, I really enjoyed that bit, actually. Maybe I'm just a sad person, but it's clever. Now, 2 and 8 there means 8 can't be here. So 8 is in one of these 3 cells, and 2 must be in one of those 4 to go with the 8. Could this be a product? 1, 2, 5, yes, very easily. I don't know, I can't really get into box 1. Let's have a look in this. I haven't really thought much about this 20 cage. If it's a product, actually it has to be 1, 4, 5. If it's a sum though, then it doesn't have 1 or 2 in it. In fact, are there any digits that are not in these cells at all possible? No. Bother. Because then I could have put that digit in the 20 cage and known it was there. Right. The remaining digits in this column are 1, 2, 3, 9. Now, this can't be a 9, but there's a lot of possibilities in this 6 cage. If it's a sum cage, that's 5 or 4. If it's a product cage, this is 6, 3 or 2. That is more possibilities than I want to be dealing with. Okay, let's have a think about the 24 cage then. One of the possibilities was 1, 3, 8. What would that leave for the 6 cage? Only 2, 4. If, on the other hand, it's 9, 8, 7, that leaves all the 4 possibilities for the 6 cage wide open. Oh, I'm finding this difficult now and rather surprising. I mean, I could come back to the fact that one of these cages is 1, 2, 3, 5 and the other is 9, 8, 7, 6. But I can't really see how that helps. Okay, the 6 cage is either 1, 5, 2, 4, 1, 6 or 2, 3. Now, all of them would create a quintuple of some sort if this was the 1, 2, 3, 5 cage. I don't know if that would necessarily make this a 9. If this is the 9, 8, 7, 6 cage, 8 has to be here, and then 8 is going to have to be here. That's quite interesting. No, I'm not getting this. I'm sure there's something else staring me in the face, something I'm very able to do and I can't see it. Okay, 6. 6 now has to be in one of these cells. And it must therefore be with a 4. Did I say earlier that 7 has to be in these? No, that could be here. But 6 has to be in these, along with 9 and 8. And therefore 4 and 1 are somewhere in this group. Oh, these two can't be products anymore, because product has to be 5, 2. So these are definitely sums, and they don't use 2 or 8. I can't say for sure that they're 6, 4 and 9, 1, but they could be. They're definitely sums though. Now, are either of these 2, 5? Six and 9 must both be sum cages, and 8, 2. 6, 4 is in a sum cage. 9, 1 is in a sum cage. 8, 2 is in a sum cage up here. Now, I can't put all of 3, 5 and 7 into the 10 cage. In fact, the maximum number of those I can put in the 10 cage is 2, which would be 3 and 5. How could I fit 3, 5 and 7 into these? Annoyingly, I could. 3, 7, 2, 5, 6, 9. No, 8 is going with 2. Ah, that's interesting. Okay, that's taken me a bit of time to work out. There can only be 1, 2 in all of these cages because we've got that 2, 8 pair. So that if there's a 2 in all of these cages, it must be in those cells. And we know that there is a 2 in one of those cells because it's going with the 8 there. So one of these is the 8, 2 cage, and it's the only 2 being used there. We must also have a 6, 4 and a 9, 1 cage amongst these. We can't have a multiplication cage because that would use another 2. That was the point of the 2 thing. And I had that in the back of my mind, but I hadn't worked it out. So these are all sum cages. Now I was going to say we can add up the whole box and work out the total of those 2 using the secret. But we can't, because this could be a multiplication cage in which the digits added up to 8, or a sum cage in which they add up to 10. So then 48 or 50. Oh, those are quite narrow options. Right. These yellow cages, which we know to be sum cages, add up to 40. This one I just worked out. The digits add up to 8 or 10. So this whole area adds up to either 48 or 50. Now that is quite interesting because these 2 cells add up to 3 or 5 because we know that every box adds up to the same total. It's always 45. That is the secret, that every box, row and column adds up to 45. Now, this is either a 1, 2 pair adding up to 3, which will make this definitely a 3, 4 cage, or these digits add up to 5. They can't be 2, 3 because that would break this cell. So this is either 1, 2 or 1, 4, and there's definitely a 1 in it, in this pair of digits. And that means these, to complete the sum, come from 6, 8, 9. Oh, the 5 in this box has to be in the 10 cage. It's not that thrilling. It can still be 5, 3, 2, 5, 1, 4, or 5, 2, 1. Not that interesting, sorry. Anyway, I've just noticed it. But if this is 1, 2, that's 3, 4. If this is 1, 4, that's 6, 2. Am I getting anything out of that? 1, 4, 6, 2, or 1, 2, 4, 3. 4 is always being used somewhere in those 4 cells. It's so close to giving me something to use, and it doesn't do it. That's irritating. This can't be a 2 because of the 2-8 pair. So that's 1 or 4. If it's 4, that's 1. If it's 1, that's 2 or 4. No, there's a 4 in one of those cells. So this isn't 4, and this isn't 6, and this one isn't 8. I knew that before. Oh, I mean, I'm so close to a breakthrough here. I've got so many stupid pencil marks all over this. Is this a problem? If this was the 1, 2, 3, 5 cage, if we got too many low digits in this column, they would all be from 1, 2, 3, 5, but then you could have 4 here and 6 here. It's not a problem. Well, it's not an insuperable problem, I don't think. I thought that was going to work for a second there. 2's in one of those cells, 2's in one of those cells. If this isn't 1, 2, it's 1, 4, and that's a 2. So 2's in one of these 2 cells. That's not going to help me at all, is my prediction. Oh, I should be finding my way through somewhere else. That's so irritating to work that out finally. So 24 cage here. 1, 3, 8 was the multiplication, wasn't it? That would leave this having to be 2, 4. What does that do? 1, 3, 8. 2, 4. It puts 4, if that was a 2, 4 cage, 4 is either here needing to go with 9, 7. Oh, that breaks. Right, here's a very interesting point that I had not noticed before. 4 cannot be in this cage because it would have to be 4, 7, 9 breaking this cell. So 4 is in one of these 3 cells. That's not a 4, and we can place 4 in box 3. It's only our 5th digit in the puzzle after 24 minutes. And it's not really getting anything done except it's taking 6 out of these cells. 6 can't be in those anymore because it has to go with a 4 now. This is my most confused area of pencil marking up here. And I don't know where that leaves me. This can't be 1, 2, 7. Now, I think I might have wrongly calculated that 2's in one of those cells. I was seeing the 2 there and thinking there had to be a 2 here, but since 2 could be there, it could still be in the 10 cage. So that was poor pencil marking. If that's 4, 1, 2 can still be here. Oh, can it? If that's 4, 1, this is 6, 9. 2, 8 is definitely here then. 6, 9, 2, 8. Ah. No. Yeah, this would have to be a product with a 4. Yes, if 2's in one of those cells, this has to be 1, 4, 5. If 2's in one of these cells, this is 1, 4, 5. And then 4 has to sit there with the 6, and that's a 1. Ah, that doesn't get anything done. Can I use that digit being 1 or 3? Oh, 3 and 7 can't both go. Ah, there we go. There we go. 3 and 7. I was nearly on the track of that when I was thinking about 3, 5 and 7 earlier, but I hadn't put 5 in this cage at the time. 3 and 7 can't both go in this cage in box 1. So one of them goes in one of these cages, and therefore the other one does as well. And what does that tell me? I think it tells me something. This can't be a 5-3-2 cage anymore. It's either 5-4-1 or 5-2-1. Actually, from the fact that 1 is in one of those cells, I think I might have been able to deduce that 1 was definitely in this cage before. But I know it for a fact now. There's a 1 there, so this becomes a 3. Now, I don't know if this is going to help. Yes, it is. That's a 1, and now this can't be 1. This is a 2. That has to be 1. Now we can start filling in these numbers. Oh, my goodness. Right. I'm so sorry this has taken so long. I feel a bit of a fool about that. 6 has to be up here, so that's a 6-4 cage. 3-7 needed to be up here now. That's what we just worked out, so that's a 3-7 cage. I can take 4 out of those. It's a 1-2-5. This is going to fill a lot of the puzzle in, actually, I think. Well, it's going to give me some doubles up here. 3-5, 6-9, 4-7-8. That's a triple, obviously. That 1-2 is looking down at this purple cage, 3 and 4. This one, by the way, I can now colour purple. It's a multiplication cage. That's not a 4, so we've got 4 in box 2. 8 is looking down here, so that's a 4. 3 is in this box, and 4 is in this box, so that's a 5-6 pair. This is a 1-2 pair. In this bottom row, I must know what this is. Yes, it's a 5. That's a 7. We get rid of those digits. I can sort out 3 and 9 based on the 9 at the top. That 7 is going to give me the 3-7 cage. Things are coming together gradually. Now, these digits cannot include 1, 2, 3, or 4. So this cannot be the 1, 2, 3, 5 cage, because only 5's available. So this is the 1, 2, 3, 5 cage, the product cage in the box. This is the sum cage containing 6, 7, 8, 9. That is actually a 5 in its column. Now, 8 is in one of those cells, so that's not 8. Can these be 9, 8, 7? We would know the order, 7, 8, 9. If it's 1, 3, 8, oh, the 8 is always here. I've just spotted that. This is either 3, 1, or, oh, it can't be 8, 9, 7 now because of these 9s. Right, so it is 8, 3, 1. It is a product cage. This is now 2 or 9. This is 2, though. So then this is 9. That 2 gives us a 1, 3 pair. Looking at this cell, making it 2. This is not able to be 3, so that's a 4 in a sum cage. That seems to have become a 1. 4, 2. That's not able to be 9 anymore. These two are from 5, 6, 7. How could this be a product cage now that 4 and 1 have gone? It absolutely couldn't. It's a sum cage. Let's do secret maths on the box. 20 plus 6 plus 10 is 36. These two add up to 9. That can't be 5 or 7. It must be 6, and that's a 3. Right, that's going to let me disambiguate columns 7 and 8, I think, probably in their entirety. Yes, looks good. There they go. Right, apart from this cage, actually that's a 7. Oh no. Oh no, something's gone wrong. Something's gone wrong in this row. Oh, it was going so well. Have I made a misassumption here? How did I manage that? I said that added up to 20 because it cannot be a product cage anymore. That's still right. 20 plus 10 is 30, plus 6 is 36. Those have to add to 9. I said this couldn't be 5 or 7 because 4 and 2 are gone. That had to be 6 and 3. Why did I then have a problem with row 5? Because I wrote a 3 into this cell instead of the 5. That's where I had the problem. Whew, that's a relief. The logic was fine, the actions were wrong. There we go, 2, 4, 3. This is a 5, 6, 7. That doesn't add to 20. I've done my maths wrong. It's not. What am I writing in? Where did I get that? That's 9, 6. Why am I unable to write the right digits? Anybody know? Don't say senility. That's just embarrassing for me. 8, 2. Right. These are 5, 8, 7. That does add up to the right total, finally. In fact, I can do row 5 now, and it looks right. That's a 6, 7, 8. No, that's a 7. Those are a 6, 8, 9 triple. This is a 2, 4, 5. Now, we can't put 5 into the 6 cage with either of those. So it's a 2, 4 sum cage. Is that the last one we had to colour? I think it is. Stop making the errors. Honestly, it would make your whole life a lot easier. Right, 6 there, 1, 2. That's going to sort out 2, 4. That's going to sort out 4, 6. Columns 1 and 2 are now completely done. And 3 even, if I get the right digit, looks like a 7. Now, that's an 8. That's a 9. That's a 6. That's a 7. That makes this 8 and 7. That makes this 8 and 9. 6, 9. 6, 5. 3, 5. 3, 1. 2, 1. There seems to be an 8 left over here. And that should be the solution. Yes. Gosh. I mean, it's a clever puzzle and it's good fun. And that's the whole point. The fact that I made a few slips doesn't worry me too much. I'm sorry if it bothers you. We will be back again tomorrow with more Sudoku variant to tackle. And we hope you'll join us. Thanks for watching. Bye for now.